So it looks like we're at the end of chapter 2. We need to start 3. We wanted to rehash the last page. A function is something that has a name, and then in parentheses, it may have a list of parameters, it may not. It may return a value back to the caller. And a module is a set of resources, and otherwise, in other words, it's a py file with a bunch of functions in it. Different definition than it was in fundamentals, where functions and modules were interchangeable terms. So a module is just a py file with a whole bunch of functions in it. Okay, so I want to hit the topic of functions real briefly. It's like one of the 3 most important concepts in programming, along with arrays and loops. So we're just going to make up some silly functions if you feel like typing along with me. I'm going to write a function called, I don't know, define hot enough. Like, is it hot enough for you? And we're going to pass in a value that gets put in this parameter variable. And then based on that, we're going to tell the person whether, they need to wear a coat or, short sleeves or, run around in shorts, something like that. So, determine type of clothing to wear. So, if the temperature is greater than 110 degrees, it's hot. Print. Wow, hot. Right? Short sleeves. elif temp is greater than, 80 degrees or 70 degrees or like 60 degrees. Print, warm. Well, I guess 60 isn't all that warm, right? Anyways, yeah, let's go with 60. Warm. Long sleeves are better. And then another elif. Elif the temperature is greater than 40. We're going to print cold. Wear a sweater. And then lastly, print parentheses quote, brr, heavy coat. Silly, right? But I think y'all's homework was something like a grade program. But this is remarkably similar, just because, like 90 and above is an A, 80 and above is a B, 70 is above a C, and so on. I think I'm going to make these greater than or equal to, like that.
Well, would it be greater than 40? Because that's warm. Or would it be less than 40?
Let me finish putting these greater than or equals, and then we'll talk about it. Okay, since these are all elifs, they're mutually exclusive. If that was just an if, you're right. Right? Because what it would do is, if the temperature was greater than 40, it would print cold, wear a sweater, right, even if it was 90 degrees outside. But since these are else ifs, since these are elifs, it'll only do one. So if that one's true, it's going to skip all the rest of this stuff. And if that one's true, it's going to skip all of this. And if that one's true, it's going to skip that one. Does that make sense? Mm-hmm. All right. Okay, and so what we would do is we would ask the user for what temperature it is. But I'm going to cheat. Just assign it a value. And then I'm going to call hot enough. Oh, bless you. And since it's 55, between 40 and 60, I'm expecting it to tell me that it's cold. Wear a sweater. So on E. Maybe we ought to make it print the temperature, right, just so we can kind of validate what it's doing. So why not at the top of the function do print parentheses it is, and I'm going to do %f for floating point number, because it might be a floating point, maybe it's 55.2 degrees outside, period, end quote. And since we have a placeholder here, %f, we got to put a placeholder here. Different than what you Java guys are expecting, where you would put a comma there. And then print out the temperature. So %temp. Now it's going to do this no matter what, right? Because that's before the if blocks. All right. That's way too many decimal points. Why don't we make it just one decimal place? So does anybody remember what I need to change that %f to display only one decimal place? Yep, 1f except .1f. .1 means one place after the decimal. If it was just 1f, it would try to fill it to one digit, but it would fail because it's a long thing. So anyways, %.1f. And what I mean by that is, watch what happens if I put a number before the decimal point, like 20. Now it says 20.1f. I'm going to undo that. You don't have to type it, but watch what happens. It pads it out to 20 spaces, which is not what we want. So if you have something in front of the decimal point, it means pad it out to that width. If you have something after the decimal point, that's the number of places to display. And sometimes it's useful to pad it out, right, if you're trying to line things up in a column. But we're not. So I'm going to get rid of the 20, and it's just %1f. All right, one more thing I want to show on the code before we go away is that everything inside the function has to be indented 1. That's different than the languages where you use curly braces. In the languages with curly braces, it didn't matter. Right, you could tab 20 times, you could not tab them all over, you can tab them at all, whatever. Something to be careful of is when you're hearing me read code, it's real easy to get the tabbing wrong, because I'm probably not saying back tab. But for example, if 1 is equal to 2, don't type this, then do something, right? Elif, if 3 is equal to 4, no, like I said, this is stupid, you know, print something. Elif, you see what's going on here, you know, or just how about an else there? Like that, okay. So, all of the elifs have to be underlined with the, lined up with the if. And I wasn't saying print, enter, back space, right, which is what you would have needed to do. So that's going to give you a syntax error of some horrible kind if you compiled it. So if you do, you just got to back tab everything to make them all line up all pretty. And if you want, you can put a return statement down here at the bottom, but it's not necessary because we're not actually returning a value. So I'm going to leave it off. You know that once you hit a line of unindented code, that it has returned by that point. And something that may be of interest is that if we did this, if I run it, and then I call hot underscore enough, and then I pass in 200, that function is still in memory until I close the shell. So hot underscore enough, -100. So if you write a function and you want to test it out, you can just run the program, and then you can sit here at the shell and type in, you know, additional calls to it. All right, loops and selection statements. Now, some of this we've already gone well over. So, repetition, that's when you want to repeat a function. Anytime you find yourself cutting and pasting something, especially pasting more than once, like if you have something in 3 places in your code, that's about time to try to make it into a loop, or to stick it into a function, or to make a loop that calls a function. So, the repetitions through the code is known as a pass, or an iteration. There are 2 kinds of loops, one that goes a certain number of times, and one that goes until the program needs to decide to stop. Like if it's going to repeat 10 times, that's a definite iteration. If you don't know how many times it's going to run, that's an indefinite iteration. What do I mean by that? Well, like, what if you're entering a certain number of test scores, but you let them type in stop to stop? Well, they may enter one test score, they may enter 10,000, right? That's an indefinite. So a predefined number of times will usually look something like this. I'm just going to type it as a comment because I don't have any code in mind to do it, so I'm going to start off a comment. So predefined loop, oh, why not? Run a specified number of times. Usually we use a for in loop, not foreign. Other languages would call it a for each loop. I don't even know what the book calls it, but something like this. For x in range 10, in parentheses, colon, print x. That's going to print 0 through 9. It's going to print 9 because this is one past the upper limit. It's not inclusive, it's exclusive. So that's a predefined loop. Excuse me, not predefined, that wasn't the word they used. Definite, right? Definite loop, not definite. Definite. All right. Another example of a definite loop. If you have a list and you're going to step through it. Dogs equals square brace, Lassie, comma, Fido, end comma, Pooch. I don't know a lot of cartoon dogs. I should have added Snoopy in there. Marmaduke, whatever. So for each, excuse me, this language doesn't have for each. For V, I'm using V to stand for value. For V, IN, space dogs, colon, print parentheses V, end parentheses. And by the way, I didn't say it, but you should have back tabbed after the print X. Dogs needs to be all the way, back against the margin. And so it printed out our numbers, 0 through 9, and it printed out Lassie and Fido and Pooch. Right, so we have this code. That line of code is being executed 10 times, 0 through 9. This line of code is being executed 3 times. The first time V is equal to Lassie, the second time V is equal to Fido, the third time V is equal to Pooch. So that's another definite loop. And so is this. Anytime in this language you see the word in, pretty much got to be a definite loop because it's just specifying a range or a series of values that is going to step through. An indefinite loop is one, let's get the book definition, until the program determines it needs to stop. Right? So that might be something like this. X is equal to 0. Let's make it 1. And then while x is not equal 64, colon, print parentheses x, and then let's multiply x by 2. X equals x times 2. Now you see, although that behavior is deterministic, if we said about it, we could figure out what it's going to do, right? We know it's going to print 1, 2, 4, 8, 16, and 32, and then stop at 64. We're smart enough to know that. The language doesn't know that, right? It can't predict when we're going to stop. It is not a definite loop. It's only going to stop when this condition is no longer true. So this is an indefinite loop. And it is going to print 1 through 32, all the doubles, the powers of 2, like that. Or, we could be making some kind of query. We could be asking the user, do you wish to run again? Or, enter a score, or stop to quit. Or, checking to see, if a stop button has been pressed, or something like that. So, indefinite loop, run until the program decides it's time to stop. This is almost, this is pretty much never. And, you know, for v in, you know, or for in, or for each loop. Instead, it's going to have a Boolean expression here. X not equal to 64. That's a Boolean expression because it evaluates to true or false. I'm going to add that as a comment here. Instead, it uses a Boolean expression. Now, can you implement things like this with an indefinite loop? Yeah. Don't type this, but because I'll delete it, but I'll show you. If we did this, x is equal to 0, while x is less than 3, colon. No, even that's not true. Yeah, that's a Boolean expression. That would do it. You know, print dogs subscript x. You know, and then we modify x to increase by 1. It's going to also print Lassie and Fido and Pooch. But it's an indefinite loop, really, because this is a Boolean expression. Now, why would you write it like that if you can print it out like that, right? That's much more efficient. Shouldn't say efficient. It's just far easier to write. And if something looks a lot cleaner, it's usually the way you want to do it. All right, I'm going to get rid of that. So that would be another example of an indefinite loop because it's a Boolean expression there. Now, just because we know what it's going to do, we know it's going to count 0, 1, and 2. It's still pretty much an indefinite loop. Oh, you just stop that. So the repetition statements, the loops, either while or for, repeat an action. Each repetition is called a pass or an iteration. I'll call it an iteration, but pass is also used. All right. So Python's for loop is the one that really does definite loops. Right? For each pass in the range, print it's alive. And again, this is riddled with typos. We've seen loops that count through a range of numbers. You use for count in range. You could also do the same thing with a while loop, if you so chose. So, for x in range, starting at 1 and going up to 10, so I'm going to make it 11, increasing by 1 each time. That's what those three numbers mean. Start at 1, go to 10 by 1s. Print x. Or you set it up as a while loop, an indefinite loop. X is equal to 1, colon. Oopsie, no colon there. I don't know why I came up with a colon. X is equal to 1, while x is less than 11, colon. Print parentheses x, in parentheses, x plus equals 1. Same thing. These do the exact same thing. I would code it like this. It's easier to read. It's no less efficient. They will both get translated, you know, into the same code pretty much.
Is there a reason that they have the two different ones?
Yeah, because going through a range is such a common thing that you want to do that it's really nice to provide a for mechanism to stepping through it, right? It's like, you know, you have bicycles and you have cars, but we really like cars for when they're, you know, for when they're functional, when they make sense. And yeah, that's pretty much it. It just optimizes the code so nicely that pretty much every language has some version of a for loop that'll step through something like that, or one that'll step through a list, a for each loop to do that. Good question, though. because yeah, why would you have a duplicate feature in the code? But it's not really duplicate. This one's behavior is very specific about what it's doing, and it's the second you look at it, you know it's counting. Whereas with a while loop, the place where it's updated may be 20 or 30 or 40 lines down at the, on the next page of code. We've been demonstrating this all along, but the assignment symbol can be combined with the arithmetic or concatenation operators to provide augmented assignment operations. Now, this is the only textbook I've ever seen that uses augmented assignment. I've seen compound assignment operators, but that's just plus equals or minus equals or whatever. So if we do this, S equals quote high end quote, and then we do S plus equals quote space there exclamation point, and then on the next line S plus equals quote space so glad to meet you exclamation point end quote parentheses, no parentheses, my mistake, and then let's print out S. So what we see is that it built all one string. That is the same as doing this. I'm going to tack one more thing onto a string. S equals S plus quote space see ya later period end quote. Right. So that's the same as the S plus equals. And you can use minus equals or divide equals or modulus equals or whatever. That's why this is there. X equals X plus 1 is the same as X plus equals 1. Your Java and C++ guys are used to using plus plus. This language doesn't support plus plus for some reason, or minus minus, I think. Mr. Python should have added support for that since every other language uses it, but I'm not smart enough to invent Python, so what do I know? So off by one errors. You need to be really careful. And that's why I keep trying to emphasize that this is exclusive and this is inclusive. Meaning that it includes a 1 but it excludes a 4. So if you see 1, 4 and you think it's going to go to 1, 4, you're wrong. It's going to do 1, 2, and 3. If you leave off the first number, it starts at 0. This looks like it's going to count 1 to 4. If you just assumed. But it's actually going to count 0 to 3 if we didn't put a starting point. So if there's only one number, it's 1 past the upper limit. If there's 2 numbers, the first one is the starting point. If there's 3 numbers, then it's something you're adding to it each time, the increment value. Like if I wanted to add 2 to it each time rather than 1. They're calling that a logic error. I would agree. It's bad logic. It's not a syntax error. It'll work. Just won't do what we want. Range returns a list. No, it doesn't. It returns something that can be converted to a list. Like if I do this, if I come down here, I'm just going to show you in the shell. If I do x is equal to range 4, like that, and then, I said x, but I typed in a, and then I print a, that doesn't look like a list. But if I do this, a is equal to list, parentheses, range, parentheses 4, end, parentheses twice, and then I print out a, now it's a list. I need to spend a week editing all these PowerPoints. Remove the little glitches in them. The book's better than the PowerPoints. So, if you do that, list parentheses range, it'll give you a list, which you could then use a for loop to step through. And then the values in a list can be visited with a for loop for something in sequence. This could be like for, when we did it in our code, we did for VM dogs. That was our sequence. Or we did for X in range. That was our sequence. So range can take a third argument. I don't know if it's why we say expects here. Expect the unexpected. We can leave it off and it just always counts by 1. One thing I'm curious about is what happens if we change that number while it's progressing. This is just a pure thought experiment on my part. Like, what if we do this? I'm going to set I, that's going to be our increment value, equal to 1. And then I'm going to create a counter, like I have been, for x in range, starting at 1, comma, going up to 10. I'm going to make it 11 so it actually will reach 10. And then do it by I, go up by I each time, print out x, but then add something to I plus equals 0.5, right? It's going to increase it a little bit each time, and I'm wondering if that's going to change how this counts. Is it still going to go 1, 2, 3, 4, 5, or is it going to go 1, 2.5, 4, or whatever? Nope, doesn't matter. This statement sets up the loop, and it doesn't matter if you change that later. I don't care if you memorize that, but like if you set this upper limit equal to a variable, like if we set z equal to 10, and then later on we try to set z equal to something else, it's still going to count all the way up to 9, or now it's going to count up to 10. It doesn't matter that we reset z equal to something else. So what happens is it sets up the loop, and then it just keeps doing this part over and over and over again without revisiting the loop except to update, the value of x. Let's make all that go away. So I mentioned using percent to line things up in tabs. So for example, what if we do this? We're going to create a little table that shows all the exponent powers of 2. So for x in range 1, 33, because I want it to go up to 32, like a 32-bit computer, colon. For x in range, parentheses, 1, 33, end parentheses, colon, print, quote, or excuse me, parentheses, x, comma, 2 star x. So like it'll print, 2 squared is 2, 2 to the cube is 8, 2 to the fourth is, 16, stuff like that. And we see it's not lined up, right? At first, this value is, the first column is 1 character wide, and then later on it turns into 2 columns wide, and if we kept going, eventually it would turn into 3 columns wide. We could make some formatted output that would look a lot better. Since these are whole numbers, and they'll always be whole numbers, I'm not going to use %f. We could, but I'm going to use %d, which stands for integer. So I'm going to come back and use formatting. I'm going to use some placeholders. So tack on another parentheses here. And do something like %2d space %, I forget how wide it got. 2, no, it's going to be a lot more than 2. I'm going to do 20d. End quote, comma, and then at the very end, we need a second closing parentheses because we added a opening parentheses there. Now, do you need all that huge amount of space? No, I just did that to make it easy to see. I'll probably backspace, remove it later. All righty, look at that. I made a horrible mistake. Does anybody see what I did wrong? Compare it to, where was that %.2f? Did I delete it? Right there. I made it %1. Right. Okay. So I had a formatting string and I had a placeholder, but then it had something after the formatting string, which was the %sign. So I got to go back down here and put a %sign here. If you're printing out only one variable, you can leave off the parentheses around what you're printing. But if you're printing out more than one value to fill in the placeholders, you do have to have the parentheses. Again, that'll look a little bit odd to the Java programmers who are used to printf, or the C programmers. Whoa. Oh, now I need to get rid of the comma. Alrighty. So after the %20D end quote, there needs to be a percent sign, and then open parentheses, x comma 2 to the power of x, close parentheses, and then at the very end our close parentheses. Didn't mean to fumble on that. Alrighty. So this column is occupying 2 spaces, and this column is occupying 20 spaces. We don't really need it to be 20 spaces, unless we're going to increase this number to all get out. Like 2 to the power of 64, I wonder how long that'll get. But anyways, we could get away with making it a lot smaller. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 would do. So I'm going to change that from a 20 to a 10. So if you want to print things in column, you're going to want to use percent. Or you're going to want to use dot format, which is actually the newer, more preferred way of doing it. It's just that dot percent works in so many languages that it's what I have memorized. I ought to learn the other format too. I keep forgetting it. Let's see if we can get it going. I ought to teach it the right way. Well, let's see how this one does, this book. I bet this book shows you the percent way that I just showed you. Yep. All right, I think I see how it works. Let's rewrite this. Just copy that statement, paste it, copy, paste, and then we're going to do a different print. Print, parentheses, quote, curly brace, 0, because this is the first placeholder. Oh, dadgummit, I already forgot. Short-term memory failure. Okay, and then followed by a colon, and then the number of spaces you want it to occupy. Forget it. I'll look it up. Demonstrate it to y'all later. Like I said, this is so deeply ingrained in so many books, give it as the example that it's what I memorized. It wasn't until Python 3 that dot format was introduced. No excuse, but okay. So, to do a floating point number, you can specify both the field width, but then you can put a dot which indicates the precision. So, if we want to print something out, putting a 0 here is kind of odd. I would just leave it off entirely. But if you did put a value there, like that, if you put %6.2, it would try to format this out to be 6 characters wide total. Right now, it's 1, 2, 3, 4, 5, 6. That would work exactly. But if salary was equal to 20, or just 5, then when it printed it out, if you didn't use percent placeholders, it would print it out like that, which would look kind of lame, right? It wouldn't show 2 decimal places. And if we did %6.2, it would take this number, 5.00, and try to format it to fill 6 spaces. So 5.00, that's 1, 2, 3, 4 spaces, but then it'd do that. right? And if we don't want to do that, we would leave off that number, and that just says fit it as small as possible. And according to the book, instead you put a 0 there, but you absolutely don't have to do that. Now, if the value you're printing is smaller than the value specified here, like go back here, and in our code, right, we said I expect this to fill up 10 values. What if it was only 5? 5 isn't wide enough to hold as large as these numbers are going to get. And you saw what happened? It got here, but then when it was no longer allowed to fit in 5, or when it no longer could fit in 5, well, too bad. It printed it anyways. It's just no longer filling it out to 5 spaces. So, when you specify a number after the percent sign in your formatted print statements, that is the minimum width that it's going to print out to. But if you give it data that's too large to fit in that minimum width, okay, it's going to go ahead and print it. If and if-else statements. Fortunately, we've already covered this. All right, so we have our logical operators. Exclamation point equals means not equals. And then you have less than, greater than, less than or equal to, and greater than or equal to. Those are so obvious that I'm not going to spend hardly any time talking about it. If x less than 3 means that it'll only go into that block of code if x is in fact less than or equal to 3. The only one that may look a little bit different is not equal to. And you do have to use double equals in order to do an if. And I'm going to come down here and I'm going to say x is equal to 100. And then I'm going to check to see if it's even. Here. The way I'm going to check to see if it's even is I'm going to modulus it by 2, right? And modulus means divide by and then see if there's a remainder. So if x modulus 2 equals 0 colon print parentheses even in parentheses. Now what if it's an odd number? Well, I can't even. We're going to have to change the logic a little bit. 2 ways to make it say odd. Well, there's an infinity of ways, right? There's always more than one way in programming. But if x percent 2 is not equal to 0, right? If you divide something by 2 and you get something left over, it's odd. Print parentheses, quote, odd. End quote, in parentheses. All right, let's do another way. Just because we like doing things. If not x percent 2 equal to 0, colon, print parentheses, quote, odd, end quote, in parentheses. These two statements mean the same thing, right? You read this one like this. If x percent 2 not equal to 0, but if you see the word not here, it means evaluate this expression, but then flip the truthiness, right? If x percent 2 is equal to 0, this would evaluate to true, but then not would switch it to false, and it would still print out odd. In general, I try to avoid using not because then your brain has to do flips trying to figure it out, just like if you're doing double negatives. I ain't not going to go. Does that mean you're going to go? Does that mean you're not going to go? You know, you're not supposed to write sentences with double or triple negatives in it because it makes it very difficult to figure out. And an or. If, let's set another variable, y is equal to 20. And I probably ought to stop and wander around and make sure that nobody's got typos. But let's do this first. If x is equal to 20, no, 100 because it is, and y is greater than 10, which it is, print cool, in parentheses, excuse me, end quote, in parentheses. If y is less than 10 and y, no, wait, or y is greater than 100, colon, print too small or large, end quote, in parentheses. This is checking outside the range. So you use or to check outside of range. What if we want to see if something's in a range? Like we want to see it's boiling or something. If y is greater than 10, except I better make it greater than or equal to. I'll mention that y in a minute. And y is less than or equal to 100, colon, print in the range, end parentheses, end quote, end parentheses. So you use and to check within a range. Could you have used this expression to check inside the range? Yeah, you could have thrown a not in there. I'm going to copy it and I'm going to paste it. I could have done this. I could have put a not here and put that inside parentheses like that, and then I could have printed out in range. Now I may delete all that. But these two things now do the same thing, right? Because this was checking to see if it was outside of the range, so by sticking the word not in it, we've reversed the state, and it proves that it's in range. But is it easy to read? Is it easy to figure it out? Well, you know, after you've looked at enough code, maybe it is, but it's not really. If I had to pick, I would do that. Or I would just throw an else statement there, right? If I'd done an else statement and printed in the range, that would have been the best thing to do. But you're not going to always be doing one or the other. You may be doing one or nothing. All right, as promised, I'm deleting that. So, and means both sides have to be true. Or it's not going to print cool. Or means if either side is true, do it. So if it's less than 10, go ahead and print too small or large. Or if it's greater than 100, print too small or large. So good old flowcharts. If something is true, then do one group of statements. Else, do something else. Now this is done with an if-else. We don't see those words anywhere in here. When I personally teach flowcharting, I go ahead and stick the word if inside the diamond. But the word else doesn't show up in the flowchart, strict flowcharting. But it could be something or nothing. Or it can be something or something else. If there's no else clause, then it's a something or nothing, like this, you know. If, you know, my name is Snoopy, then I could come over here and print cool, except it ought to be in a tilted rectangle. And then I come back like that, right. I'm either going to print cool or I'm going to do absolutely nothing. This is the true side. And y'all over there can't see that. People watching at home can't see it. Just imagine. All right. So, if there is no else, then there's only one side being done. Now, personally, I like putting the true clause up here and the false clause over here. If in flowchart. I don't want an if-else. I want, here we go. This is a standard if, right here. If the condition is true, do something. If it's not true, don't do anything. But then there's the other style. True or false. If the condition is true, and again, I draw it going to the right because the other one was to the right, right? Do something. Else, do something else, right? And if you're going to use if, elif, then the flowchart starts to look a little bit weird. So I'm not going to bother trying to flowchart that. They may do it. And here's our grade. Did we do a grades assignment in this class?
We did a try error, was the last one.
But I didn't actually give you a homework called grades. All right. Well, here's the idea. We want to use if statements print out whether you've made an A or a B or a C or a D or something like that. So the logic is going to look something like this. If grade greater than 89, print B. Elif grade greater than 79 and below 90, print B. And if grade, well, let's try to code it just as the logic shows. And I disagree with the logic. We will change it. They change it too in their example. Okay, so here's what they got. I'm just going to arbitrarily pick a grade, 95. I want to see it print an A. So if grade greater than 89, colon, print, parentheses, quote, A, end quote, end parentheses. Then elif, well, or you could just do it all with else's. All grades above 79 and below 90. So if grade greater 90 and grade less than, I've done that wrong, greater than 79 and below 90. So backspace. If grade less than, why is my brain broken? Above 79 and below 90. So if grade greater than 79 and grade less than 90, colon, print parentheses, quote, B. Now this example now is all jacked up. What would it print if the grade was 89.5? Let's find out. It printed out A and B. Well, I tend to round up. Like if you're making an 89.5, I'd probably round your final score up to an A. I don't want to be a jerk. But that's certainly not right. They ought to be throwing in some greater than and equals in here. But the best way to do it, to fix this, is to use if elifs. So if it's greater than 89, and honestly, I think that ought to be greater than 90, right? And it ought to be greater than or equal to 90. So if grade greater or equal 90, colon, print out A. Next line, elif grade greater than equal 80, colon, print B in parentheses, else, colon, print F. Man, this is a hard teacher. All right, and so 89.5 did turn out to be a B. The reason I would do it this way, rather than the way that I was doing it before, is the conditions are easier to manage. You could get the other way to work if you were very careful. But if you just use if elifs, then it works great. Now, one thing that people tend to do wrong, I'm going to go ahead and type this and don't, maybe I'll put it in a comment, is if you do this, if x, if 5 less than x less than 10, or if 5 less than equal x less than equal 10, they think that's going to work. Why? Because it worked in algebra or geometry or whenever you took this language, right? It means x is a value between 5 and 10 inclusive. That doesn't work in this language. You have to use and. You could do if x less than or equal to x and See? I've already broken my brain. Here's how you'd have to rewrite that. If x is greater than or equal to 5 and x is less than or equal to 10, colon. Just kind of have to do a brain flip, but each side of and has to be something that evaluates a true or false. So you can't just stick one number there. You have to put a whole expression there. Each side of less than or equal to has to be a true or excuse me, a numeric value because you're comparing things. And in this case, it's not, right? Because once that was evaluated, it becomes true. And then is true less than 10? Doesn't mean anything. That's not even the best example of a way that you can mangle this syntax. What if you want to see if somebody's input is equal to the letter uppercase Y or lowercase y? If choice equals, and this is not going to work, lowercase y or uppercase y, do something. This looks so good, and it doesn't work. I better put some comments about what's wrong and what's right. Wrong, right, wrong. Instead, you would do if choice equals lowercase y or choice equals uppercase y, colon. That's right. See what I mean? Both sides of the or have to be a valid expression. You know, once this is evaluated to true or false, then that whole thing goes away, and the rest of it had better be a valid expression. Something with an equal sign or greater than or less than or something like that. Hope that makes sense. If you get stuck on it, text me a picture. I'll look at it. I'll circle the code, send it back to you, tell you what you need to do wrong. Or not what you need to do wrong, what you need to fix. Just remember that both sides of and or have to be complete expressions. Also, you're not allowed to express ranges in the classic algebra syntax. We have to be a bit more precise, a bit more detailed. Here's an example of chained ifs, also known as an if cascade. An if cascade is when you have if, elif, 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 elif. They're not showing elif in here. They're just leaving it for us to figure out what keyword would go in these blocks. And I disagree with that style. I teach something different when I'm teaching flowcharting. But something like this. Let's declare a string. S is equal to cat, end quote. If S equals, quote, dog, end quote, colon, print, woof, exclamation point, end quote, in parentheses, else, colon, I'm messing this up on purpose, if S equals, mouse, end quote, colon, print, parentheses, quote, squeak, end quote, in parentheses. And I'm not saying backspace, but so you're going to have to watch really carefully when you compare your code to mine. Else, if S equals cat, end quote, in quote, colon, print, parentheses, quote, meow, end quote, in parentheses, backspace, and then else, colon, print, silence. All right. If it's not one of those things, we don't know what it's going to do. Now, a cascade is a series of waterfalls. I think that's the definition for it. Like you go to the Cascades somewhere. You can kind of see that this looks like a staircase, right? But there's a far better way of wording it, which is just you use elifs. Why did we even need to use if entirely? We could probably, in this case, get away with not even using else, because these are all mutually exclusive choices. But when we were doing grades, it would not work. You want them to be mutually exclusive. You only want to print out A or B or F and not get into a situation where it's printing them more than one thing. But instead of else, if, we're going to do elif. So highlight all that, delete it, and then backspace the else all the way to the border and do the same thing. Highlight all that, delete it, and then backspace this else against the margin, and that's good enough, except it would look prettier if we lined up the other code as well. Oddly, that'll work, but it sure would look better if I did that. Right, so it's going to execute one of these mutually exclusive options. If they were just else's, they would not be mutually exclusive. Forgive me for a moment while I squeeze back up to our grade stuff. if this was just an if statement like that, then if your grade was 95 or 100, I'm going to undo those changes, don't bother. It would print out both that you had an A and then that you had a B, right? Because if it's greater than 90, print A. And then if it's greater than 80, print B. We don't want it to print both A and B. We want them to be mutually exclusive choices, so I'm going to undo those changes. Right, so that one is now an elif again. So I'm going to add some comments. Use if elif to create mutually exclusive choices. You should always have an else at the end to catch unexpected states. What do I mean by that? What if I always thought that this could only equal dog, mouse, or cat? What if there were no other possible choices? The user couldn't possibly be stupid enough to type something else in. And then the user types something else in. We would want an else down here to handle it. Right? We could say unexpected value and then print out the value, right? We could tell, or I don't know what a, So instead of silence, I'm going to print out something a little bit better. Like print, parentheses, quote, unexpected value, end quote, comma, S, end parentheses. So now if it doesn't equal dog, mouse, or cat, we would get that message, letting us know that something was wrong. I'm going to change cat to something else just so I see that. Like I'm going to uppercase it. Capital C-A-T. All right, and it runs, and it says unexpected value cat. Now the message could be a little bit clearer, right? But anytime you have some if, elifs, go ahead and tack on one more else at the bottom to handle unexpected states. Trust me, you can save some grief. You can look a long time for that error and not understand why it's not doing what you want it to do. So and or. This is what's known as a truth table. If A is true and B is true, then A and B is also true, right? And I always give these examples, so if you've taken another one of my classes, you're familiar with them. If you are hungry and you have money, go to the store. Go out and eat. But if you're not hungry, if A is false, but you still have money, well, it'd be wiser to stay home. Or if you're hungry but you don't have any money, then you're going to stay home. False. And if you're not hungry and you don't have any money, well, you certainly ought to stay home. Unless you're just going to go hang out with a friend and watch them eat. Now, or means one or the other, right? Are you sick and tired? Well, if you're sick or you're tired, stay home. If you're sick but you're not tired, the second case is false, still stay home. We're generous. Your boss likes you. If you're not sick but you're tired, go ahead, stay home. And if you're neither sick nor tired, that's the only time you'd better go to work, right? So A and B, the and is only true if both inputs, both sides are true, both operands are true. A or B, it only evaluates to false under one state, which is if they're both false. And then there's not. I already showed you the not keyword, which just flips the truthiness of it, right? Flips the state. If it was true, then not A is false. If it was false, then not A becomes true. All right, so we're going to make a little program, and it's not going to be terribly complicated, but this is going to be my homework assignment. Ask the user to enter a number. If the number is equal to 1, use a loop to print out the numbers from 1 to 10. If the number is equal to 2, use a loop to print out the numbers from 11 to 20. If neither of those are true, print I don't know what to do. All right, that's one thing. All right, just a second. I'm going to okay, I'm not finding it. So that's part 1. Part 2, ask the user for the mass in grams and the volume, let's make it in CC stands for cubic centimeters. Calculate density, which is mass divided by volume. And if the density is, let's get some fun values. What's the density of oxygen in grams per milliliter at? .96. All right. I'm just going to do water. If the density is equal to 1, print out that the substance is equivalent to water. If the density is less than 1, it's light, and so it's going to float. Print out that the substance will float. If the density is greater than 1, print out that the substance will sink. So that's part B. So while we're at it, have I done the kind of loop where I ask you to print out like all the numbers forward and backwards? Not sounding right. Okay. So, C, print out the numbers from 100 to 200, skipping by tens. And then D, print out numbers from 200 to 100, skipping by -10. All right. So, hints or wishes or something. Hints. Use elif and else where it makes it easy to code. You should be able to avoid using or and and. Now if you have to, that's okay. And then for C and D, it'd be easiest to use for loops, to use for x in range loops, which we've given examples of, except I don't think we gave an example of counting down. So why don't we do that before we call it a day? All right, so I've already talked about counting up, right? That looks like something like this. For x in range, you're starting at 1, you're going to 10, which is actually going to stop at 9. You want to increase by 1 each time, right? Print x. But what if you want to count down? Then the first number is going to be larger, the second number is going to be smaller, and then the third number is going to be negative. For x in range, starting at 10, going back down to 1, by negative 1s, colon, print x. Now, what's this really going to print? It's going to print 1, 2, 3, 4, 5. What's the last number it's going to print? Don't tell me 10. Right, it's going to go to 9. So this is going to print out, 1 through 9. Well, here it's going to print out 9, but because of the, it's going to print 10, but because of the minus 1, it's going to print 9, 8, 7, 6, 5, 4. Somebody want to hazard a guess at what number it's going to stop? It's going to stop at 2, right? Because once it hits that number, it's gone too far, and so it stops. Remember, this is exclusive, so this will print 10 down to 2. If you wanted to make it print even numbers or skip by 2 each time, you make it, comma 2 rather than comma 1, and so on. So I'm expecting this to say 1 through 9 and then show 10 all the way back down to 2. Yeah, like that. That's the first loop, and that's the second loop. All right, guys, that makes sense? Probably a short one for you. These will be getting more challenging as we go along. Hopefully we'll be moving out of the stuff that you may have already learned in fundamentals pretty soon. But half the class doesn't have fundamentals, so I'm not going to leave y'all behind. Any questions? Nope. Alrighty. Well, let's make a Dropbox. This is for Dropbox E. Go and find that.